All right. Thank you very much for joining today's class. For those who don't know me, my name is Clement Chumesi. I am a final year PhD student studying mathematics at Cardiff University in the UK, and I'm also a Vice Chancellor Scholar of the university. So that's just a quick summary about me. But if you've not watched our previous video or previous meeting, you can stop and watch the YouTube video of the first lesson before you proceed with this one. Last week we started with introduction to advanced data analysis in R programming software. There were a lot of things we did. We actually spent over 1 hour 30 minutes, and we learned quite a lot. And some of them, I just wanted you to have a fair idea. So today, I wanted you to digest as much as you can, so that now, if you are now explaining certain things, you would embrace everything. So for the first phase, I'm going to give a little bit motivation, and also a fair idea about how you should be searching for other information. Someone was like, after going through the materials, he was expecting to be able to do more than we've already taught. And I was telling the person that programming is just like trying to learn how to drive. You know, when you go for your first lesson as a student, as a learner, trying to learn how to drive, you cannot just start thinking about driving on the highway or on the motorway. It's just a process. It's just a matter of time. So you don't have to push yourself too much. You don't have to just relax a little bit, and then give yourself, let's say, 2 months, 3 months, and even a number of years. Keep in mind that everyone learns over time. So it got to a point I never knew that I could create, let's say, a fish heat map in R. I didn't see any software, and I've never seen anyone doing that. I never thought I could. By the time I realized, I was able to do something like that. So what I'll say is that keep in mind that it's just like a learning curve, okay? And it's just like you are learning. One thing you have to notice that you won't know everything at the beginning stages. It takes a lot of practice, and it takes time to become strong. And when you get there, you feel motivated. Okay, so now one thing I want you to also note is that with programming, one thing is, if we're able to import your data, technically, you don't even need me again. If you're able to import your data into any programming software, whether being a programming language or any of the statistical softwares like SPSS, Stata, and the rest, once you're able to import your data, you technically don't really need me. But why do you need me? You need me when you now want to do proper programming, in the sense that after importing the data, if you want to do any other thing, the first thing is the internet is your friend. The first thing is how to do this in R. Just Google. Anything you Google, as far as it's programming in any software, anytime you Google, let's say you want to maybe do some bar plots in R, you don't know how to do it. Just Google how to plot, let's say, bar plot in R. And then you will see a lot of online, codes and other things trying to help you. So this is how I learned how to do analysis in different softwares, not necessarily R. So with Stata, this is how I started. I never knew Stata in the first place, but I was exposed to R because I use it for my undergraduate research. So what happened was there was this PhD student doing actuarial science in Kwame Nkrumah University of Science and Technology, and I was in University of Ghana. And he was looking for someone to help him make a prediction using a model called Arch model. Arch model is like autoregressive heteroscedastic model. It's just a time series model to help estimate or predict volatilities in prices or fluctuations in prices. And I didn't know anything about that, and I didn't know anything about Stata in the first place. Okay, so I'm just trying to give you a little bit. So whatever I'm saying in Stata, you can use that same ideology to motivate yourself. So what happened was I didn't know anything about the software. So he came to my department. He said he asked almost a lot of lecturers in the study department in KNUST, which is Kwame Nkrumah University of Science and Technology. He couldn't get any assistance. He came to the University of Ghana. He was asking around, and he couldn't get any assistance until some of my lecturers told him to come to me. I didn't know anything about Stata in the first place, and I didn't know anything about the model itself. But I knew a secret, and that's the secret I want you to keep in mind. The internet is your friend. You cannot survive in our current generation if you want to learn whether programming or any of your academic endeavors by throwing away the internet. The internet should always be your first point of contact. So what happened was the first thing I needed to do is how to. So when he came and he told me about the problem and the fact that he has struggled to even get to me, I just told him, okay, that's fine. So what we'll do is that um, come the following day, just give me your data and come the following day. Okay. So when I went, what I did was first of all, how to install Stata. And then I just went online. I was able to download Stata. Now the next thing is how to import an Excel data into Stata. And I just Googled. By the time I realized, I mean, there were YouTube videos. By the time I realized I had imported it. And then the next thing is, okay, how to fit the arch model in Stata. Keep in mind, I didn't know anything about the software in the first place. I didn't know anything about the importation. I didn't even know anything about the model. But it's just starting with the Googling, okay? So then how to do the arch model. And then by the time I realized within just 30 minutes, I had installed the software, I had imported the data, I have now been able to fit the model. And the next thing was how to make the prediction. So I just Googled how to predict after you have your model, how to make predictions from it. And I just got a single line of code. And by the time I realized, I have now been able to do the person's task in Stata for him without knowing anything about the model, as well as without knowing anything about the software. Use that same principle in R. So it means that once you're able to import the data into R, most of the things you just have to start as a beginner, you just have to be Googling, especially if you want to do anything that you are struggling. Don't sit there and suffer, just Google. So that's one thing I want you to keep in mind. And then don't expect to be able to do the things maybe I'm able to do now. It just takes a lot of practice. Keep in mind, it takes a lot of practice. I started this thing back when I was in my final year of undergraduate. So just imagine how many years now, over 6 years now to 7. So it takes a lot of practice and then you become stronger afterwards. So don't worry. All right. So now we are going to start with our main objective for today, which is we are going to do some programming and data analysis. So I'll start with a little bit with RStudio because I wanted to explain some certain few things for you to understand, and then I'll move to Jupyter Notebook because that's what we'll be using, or I will be using for the subsequent class. But I just wanted you to be familiar with certain things I didn't say last week about the RStudio. So I'll share my screen now, and okay. All right, so I guess you can see the screen now. All right, so please don't forget that this video would also be uploaded on YouTube, and don't forget to subscribe and then share with your friends because the focus is that we are trying to help motivate especially African students into mathematical programming, but any other person is also happy. I'm happy for any other person to also join. Okay, so suppose we don't have this, so let me delete this. So let's assume you've opened your RStudio, and this is what you see. So the first thing is last week we learned that you first of all create a folder, and then that folder is just basically going to serve as your repository. I'm going to show you something to know why it's so important to always have set a working directory to make life easier for you. So now I'm going to call back the script that we've already used, the script we used last week. So all I need to do is I just have to go to File, and then I go to Open File, and then I go to my desktop and I locate data analysis, and that's called R because that was the folder. And this is what I want to import. So I just click on it, or you just click and open, or you just click on it. Fine. So now I have imported the script. So this is how easy you can import any script into R. Okay, and now you've already learned how to set working directory. So I wouldn't go into that details. So you just have to copy the link and then you paste it here. And after pasting, make sure you change the slanting bar instead of facing to the left, which is going to be the original default. You then change it to the right. So I wouldn't go into that details. All right, so now let's run this. So to run, you can either let it blink and then click run, or you highlight the particular command and then you run. Okay, so there are two ways to run in RStudio. Either you let it blink or you highlight. But sometimes it's advisable to highlight because suppose you have a longer block of codes, then you would want to highlight up to the point you are interested in, then you run. Okay, so don't forget that. Now, what I want to explain is how to install packages. So first of all, what is R packages? What are packages in the first place? So last week we learned how to create our own complex functions. Today I have made it very complicated, and I'll take you through and make you understand everything. But keep in mind that every code we are running or every code we are creating now, you have to save it for future use. So all what we are doing is not something you have to throw it away. No. So for me, I have access to all my codes I've been using, let's say 6 years or 7 years ago. So that it's not now that you're going to create your own function to do the summary statistics. You already have it. And the summary statistics function we created can be used for any data. And that's why we created it to generalize it. Now, the function that we created, do you know we can actually write a package with it? And then it will be like our own package we've actually developed, right? So what we mean by the package is that someone writes his own function and then wrap the function around with a certain package, so that now if you're able to install and load the person's package, you can be able to use the person's function. Okay, so that's the essence of the packages. So packages means that you want to do a particular task, but that particular task, let's say you want to fit maybe a generalized linear mix model, you don't know how to fit it, but someone has already written a package for you to do that easily. Okay, so all you need to do is that identify the package and then and install the package. After installing, you have to, don't forget to load. So we use the install.packages to install the package. And don't forget, there's always a quotation sign before the name of the package. But the beauty about RStudio is that alternatively, let's say I want to install this package called Movement. All I need to do is to come to this side. Have you seen packages here? Just click that and click install. Then type the package name. So if you know the package name to be Movement, once you start typing Movement, then it start popping up, then you select and then just click install. So once you start clicking install, let's give a little bit of time, then it will start. So you realize that it has started running and the command it wrote was install.packages, which was actually what we wrote already, okay? So it meant that if you don't want to worry about trying to write install.packages before, just come to package here, click install, and then type the package name, and then click install, and you are good to go. Now, the very moment you see something like the package successfully unpacked, then it means that your package has been able to install successfully. And after installing, you cannot use it until you load it. So keep in mind, you always have to install the package first, then you load. How do you load? You load with the function called library. So now keep in mind, when I was installing the package, you realize that there's a quotation. But when I'm doing the loading, I can either bring the quotation or not. If you bring the quotation, you don't have any problem. If you don't bring it, if you don't bring it, there's no problem. So now I'm not bringing it, there's no problem. Okay, so keep in mind that's basically how to install packages. But some versions of R might not help you to install certain packages. So suppose, let's say I want to install as another package, for instance, called Ggplot. So I click, which we'll be using today. So I click here, packages, install, and I just start, I start typing the name. So Ggplot, then I select this, then I run, I click install. And keep in mind, without internet, you cannot install your packages. But after installing, and suppose you are using your own bundle, after installing the package, you just have to, you don't need the internet anymore. But once you want to install a package, you need an internet. But after installing the package for the first time, you will not install it again. It will be there for the rest of your, as far as you are going to be using the software. So the very moment you start seeing messages like the package successfully unpacked, then it meant it has been installed successfully. But there are instances where some versions will not permit you to be able to install some specific packages. When it happens that way, what you need to do is, someone told me yesterday that he wanted to install Ggplot 2 and he couldn't install. Okay, so what you need to do is that just go to Google and type installing Ggplot and add, like, say, install Ggplot and add GitHub. Okay, so you can just type something like maybe install maybe Ggplot to GitHub, GitHub, then I add R. So let's try it in Google for now. So keep in mind, some versions of R might not be able to allow you to install certain packages. It doesn't matter whether you are using high versions or not. You can be using the latest version. You might not be able to install some specific packages, but someone using a lower version might still be able to install that particular package. So keep in mind, it doesn't matter the version you are using. At some point, you might not be able to install some packages using the normal click and install.packages. It might not work for you. But always, that's the first thing you need to do. You do that. If it works fair enough, then you have to, don't forget to load it. Without writing library around the package, you cannot use it. Keep in mind. So now let me stop sharing and go to Google and show you. Suppose you wanted to install Ggplot 2 and it wasn't working on your the version of R you're using. How would you go about it? Okay, so I'm going to share my screen. Okay, fine. Okay, so please, can we all see? Let me. Okay, so Google. All right, so I've just come to Google now. So suppose I wanted to install Ggplot, and after trying the normal install.packages in R, I realized that it gave me an error message that the package cannot be found. In that case, I just type the install that package name, then I add GitHub, then R, then I run. Once you run, you can just click the first link, and then I click on that. So once you click on the first link, you just come down. So this is a typical GitHub website. So I come down. So when you come down now, can you see that you've seen this code here? So technically, this one is the easiest way, which is the standard way that I explained to you earlier. And I told you that you can either run that directly, or you can just, if you're using RStudio, you can just go to that and click and then enter the package name and you are good to go, right? So you can just watch the video once again to look at that. Alternatively, you can install this package called DEV tools. This package helps you to be able to install packages from GitHub directly. So meaning that every R package has been put on GitHub. So meaning if you are doing the normal installation and it's not working because of the version of R you have, just type the package name, install the package name, GitHub R, and then open the first link or whatever link is useful. And when you're opening, your aim is to see something like install _ GitHub. Once you see that, you can run this particular, you can run that particular line on your RStudio, okay, in your script. You just copy and paste in the script or directly into the console, and then you run. After running and it works, don't forget you don't need to install again. Anytime you want to use the package, use the library to load the package. So this all you need. So I just have to copy this one, and then and keep in mind you have to install DB tools first. For DB tools, everyone should be able to install no matter the version of R. And then after installing, you can either decide to load it. So let me copy this one. Let me stop sharing here and open and share RStudio. Okay, fine. So suppose I didn't suppose the Ggplot wasn't working on mine. Okay, like after trying to do the normal installation, and I went to Google and I got it from GitHub. So you can either load library, then DV. You realize that once you start typing, the package name pops up. So I ran this. Oh, let me take this up here. Okay, so I ran this. I realized that after running how do you call it? I'm getting some error message for mine because there was a little bit problem with my DB2. So I was using something else, but with yours, it should work fine. So you can run library DB2s and remove this one and just run the install _ GitHub and it should work. Or you can decide not to bring the library. So anytime you don't want to bring the library, you rather will bring the name of the package and the double column. Okay, but I think that's just long process. You can either run that and you're good to go, or just load the package and then use the function. Or you can bring the package name. You can bring the package name and then bring two columns, and you are good to go. Okay, so that's all you need to know about package installation. That is it. Okay, so now last week we didn't produce any graph in RStudio, so I'm just going to produce one quick graph, and then we start everything in Jupyter Notebook. The graph is just for you to see where your graph will pop up after you produce any graph and how you save it. So that's basically what I'm trying to achieve now. All right, so we've set the working directory. Now I'm importing the data. I just have to run this. So it means, suppose next time I've given you this a different data set. All you need to do is to change the name of this data set to suit how you have saved it, and you should be fine. So importing CSV file now shouldn't be a problem if you watch the first video. All right, so now suppose I want to produce a certain plot quickly. So don't worry about this. I just want you to see where the plot will go. So let's say I want to produce histogram. Okay, then I bring my data, and then I bring the dollar sign, and I select, let's say I want to plot the histogram for the number of teachers. Okay, and then so this is the histogram, and you can always specify the color you want by using this. The call here means color. So suppose I want blue color, I just put blue here. If I want red, I just put red. So suppose I want to put a heading to the graph, I bring main, and the main is saying that histogram plot, for instance. Okay, and then if I want to label my x-axis, if you don't specify these, it will run. So for instance, let me run this. So if I run this, now see where your graph popped up. So this down part is where you see your graph. Okay, so to view your graph, you can even click zoom, and you see a very big graph. And then to save it, you click export. Have you seen export here? Click export. If you want to save it as a PDF or you want to save it as an image, so you click image, and then give any name you want to give it to. So suppose you want to save it as maybe his maybe teachers or something, histogram of teachers. Then you just click save. Now look at something. Have you seen it has specified the working directory here? So meaning that once I click save, it saves directly into the working directory called data analysis underscore results. So that's the beauty of setting a working directory. So meaning that after setting a working directory, any graph you produce, you just have to click export. If you want to save it as a PDF, you click on PDF. If you want to save it as an image, you click here, which is always advisable to save as an image. You can save it as a PDF if you are someone who have been using LaTeX for your report writing instead of Word anyway. But you can also import a picture as well. And then you specify the name. Once you click save, it will save directly into your working directory without any effort. Or you can alternatively just go to Google and type how to save a graph or a graph in R into your repository. But this is the easiest way. Once you've set it, just click export and you are good to go. All right, so this is all I wanted to explain with the RStudio for the first 10 minutes, just to know how to easily install a package. So to install packages, you just click on package here. Okay, just click on the package, click install, and then put the name of the package. So for instance, let's say you want to do, let's say a particular model or something in R. Then you went to Google, you type Google, and you Google whatever you wanted to do, and you saw some range of codes. And the first line you saw was the person has written library in brackets, some package name. Anytime you see library, whatever is inside is a package. Anytime you see live, so suppose we're searching how to do maybe generalized linear model in R. And then when you Googled, you saw that the person has written a block where they've written range of codes and the results and everything is down there. All you need to do is that, first of all, once you see they've written library in brackets, whatever is there is a package that you need to install. If you don't install, you'll not be able to run some of the functions the person has done down there. Okay, so always keep in mind that when you see library in bracket, whatever is there is a package you need to install. So suppose you saw the package as, let's say, LMER. Let's say LMER test. So let's say this was a package. This is one of the a package for generalized linear maze model. So suppose this is the package you wanted to run. Okay. So all you need to do is just click, put the package name here and click install, and you are good to go. Okay. So I'll stop with the RStudio now. And after the package, don't forget to load with the library. Load with, you load with the library of the package name. When you're loading, you can choose to bring the semicolon or not, it doesn't matter. But if you don't want to use the normal package here, click install. You can use this function, install.packages, because that's exactly what does for you, right? Because that's what you can see here, okay? And then so you can use the command line, or you can do it like manually as I showed you. All right, so we'll stop here with that and start with serious programming in Jupyter Notebook. But everything I'm going to do, you'll be doing in RStudio. So it means at the end of the day, I also send you the script, and then you see the advantages of RStudio. You realize that everything I do, I can save it like an R script, just like as you are seeing here for you. And at the same time, I can save it as something else, which I'll explain shortly. So let's start with the Jupyter Notebook. So I'll share my screen. Okay. So um so let's start. So basically, when I talk about Jupyter Notebook, so Jupyter Notebook is just an IDE, okay? And last time I explained IDE is just integrated development environment. And what they do is that they help you to run programming languages. So even though R is a programming language and could be run in R base or could be run in RStudio, you can actually use Jupyter Notebook to also run R. Why? As you can see, let me go up here. As you can see, I can even make notes, and you can see all my codes are there, and the results. Last time I imported the data, and you couldn't even see the whole data. See, here you can see I've imported the data. You can see the data. When I come down here, you can see all the results. I can even write functions I want. And then if I come down here, you can see anything I do. So it means I don't have to be saving, I don't have to be copying and pasting my results into R. You remember just in RStudio, what I did, I had to save it manually into the repository, isn't it, or the working directory. But here, I don't have to do that. It's there for life. So it means all the plots we are going to go through, everything is there, and I don't have to go and save it in the folder. Everything will be in Jupyter Notebook, and you can always call it back. So every time you have the plot, your course is there, and the plot, and you realize that it makes your course very neat. So especially if you are doing a PhD or sometime a time to come, you are going to have supervisors. The advice is that suppose you run your course, your supervisor will be able to see your plots just beneath it, and it makes supervision and actually sharing information with others very easy. So keep in mind, this is the software, as in this is what in some future time we'll be using to be running R. You will see all your plots just below it. Your codes are there, your graphs are there. If I want to save this graph into the R repository, I can just right click the R. If you want to maybe copy and paste into Word, you can just click copy and just paste. That's it. If I want to save it into, let's say, my repository, I can click save as and just go and save as and just go and manually select my repository and then give the name and click save. That's all. So it means that's one of the beauty about this. Now let's look at another thing about the Jupyter Notebook. So first of all, let me come here. So as you can see from here, let me come here. Okay, so first of all, when I click this part, you can see three different programming languages. One is Julia, Python, and R. So it means technically I can run Julia, I can run Python, and I can run R at the same time. And one thing about, if you compare this with the RStudio, you realize that with the RStudio, you can, even though you can import as many data as possible, you realize that in RStudio too, you can also import several scripts, isn't it? But with the beauty of Jupyter Notebook is that you can import different scripts, okay, and then even different languages at the same time and be running them at the same time, and you don't have any problem with anyone. So that is that. And then when we come back to the actual script we are going to use for today, if I click file and I go to download as, if I click file and I go to, I'm coming, because they're sharing it, okay, download as, you can see I have different options I can download the script as. If I click R, it will download as the normal R script that we did in the RStudio. So everything I've done here, I'll share everything with you as well. But if I click this particular option, it will download it just like the normal script you wrote in RStudio. If I click on this, it will download as latex. So those who have been using latex, you can actually download this and run as latex. And then if I click on HTML file, it means that you'll be able to see the codes, the graphs, and you open with any of your browsers, and you see the codes and then the results, and then you just use any of your browsers to open. Okay, and it means no one can edit the codes or the graphs. So suppose I want to send you this particular results, which I'm going to do. I will send it as a script and also as an HTML file. So the HTML file is to click on it, and then it will open with any of your browsers, and you'll be able to see the codes exactly as you are seeing. Everything with the graphs and the results will be there, and you get it. So that's the beauty about about Jupyter Notebook. It helps you to manage and organize your codes. Okay, fine. So now let's start with some business. All right, so we are done with the packages, and then yeah, so here, before you start RStudio, Jupyter Notebook, keep in mind in the RStudio, once you start typing, your codes pop up. You will not get that option if we're using RBase or if we're using Jupyter Notebook. Okay, so it meant that here, suppose I want to type, let's say mean. If I type mean, nothing will pop up. If it's RStudio, something will pop up. Okay, so that was the reason why the RStudio was always the first point of contact if we are starting programming in R for the first time. Okay, but when you become a little bit okay, I think it's advisable to switch to the Jupyter Notebook, because it's like, as you can see, you see your codes, you're able to organize everything. And if you are going to share, let's say it could be a presentation, you can actually use this Jupyter Notebook as a presentation. Suppose you are presenting to a firm or your supervisors, you can actually do this. Write anything you want, your codes, everything is just down beneath it. Okay, so keep that in mind. All right, so now let's start some business. So now I'm setting the working directory. To run, I just have to click Control and Enter, and I'm okay. So I've run the first line, and this line is just to help me, because some of the new R Jupyter Notebook, once you plot a graph, it will plot using half of the page. But I use this one so that it will plot. I ran this one so that it will plot like a normal big page. So all the big graphs you saw was because I was able to set how large I want my graph to be, and the resolution. If I want my graph to be the resolution to be very high, I can change this one to 400, but 300 is okay. And then the width 8 and height 8 is okay. So you can use this one. That is if we're using Jupyter Notebook to run R. Okay. Now these packages are something I'm going to install. Okay, so that was why I went through a little bit stress to explain how you install the packages. So suppose you Google something and you saw my script here online, and you saw that I've written library in bracket something, library in bracket something. Whatever is inside is a package that you need to install, or else you get to some point, you will be getting errors. Okay, so because I'm using someone's function at some point, and if you are not able to load the package that will help you to be able to use the person's function, it implies, you get errors. All right, so you are going to install the package called Movement, and now you know how to install packages in RStudio. If you don't know, you can just use install.packages, and in bracket, then you put the name of the package inside the quotation and just run. You are good to go. And don't forget that after installing, you don't need the install.packages for that package anymore. So you realize that when after installing the other packages, I don't have to bring install.packages anymore. So I just brought this hashtag as to comment this one because I don't need it. Okay. So now I just run my packages. Okay, so now I've run my packages. There are instances once you run your packages, it has installed all right, but you see as if some error messages coming down. It's not an error message. When it happens that way, just run it again. So suppose, let me add a package. Let me run library, let's say TD, is it TD? Let me see. So something like this. So when it sees an error like this, it's not an error. This warning message says that it was built under R version 3.6.3. That's not an error. I'm using a different version, but it allowed me. Once I run it again, it goes. Okay, so when you see something like that, it's just a warning message and it's not an error. Now I'm importing the data. So remember read.csv the file, then I put the name of the data here, then I bring the .csv, and don't forget your quotation. If you forget the quotation, you get an error. So suppose I forgot the quotation and I run, I'll get an error. So you see error, and the error is saying that this cannot be found. All I needed to do was to bring the quotation around it, okay? And then I specify the name, sorry, school, and I specify, so it's school, okay. Then I specify the name of the data, okay, fine. And then the head, I told you last time that if I don't bring anything here, and I just run head in bracket the data, it returns just the 6 rows. Someone was asking in the chat message last week that what is a vector? And they were wondering whether we are talking about physics, vector in physics. No. I want you to keep in mind that we have something called data structure. So in any programming languages, we have different data structures, okay? So first of all, the data structure can be seen as an array. Can be seen as an array. What do I mean by array? Array is ARRAY. So so what I meant is any data structure can be seen as an array. This is what I mean. But the array could be one-dimensional, okay? It could be one-dimensional or it could be two-dimensional. So the one-dimensional is what we will call it a vector, okay? So meaning that now look at this particular data. The data has rows. So right now we have 6 rows and 8 columns. So as you can see, it's 6 by 8. So this 6 by 8 is a data frame, but it is saying that if I want to know the entire dimension of the data, I just have to put DIM. When I run this, my data has 19 rows and 8 columns. So something like this is a 2-dimensional array, okay? Because we have it can be described by a row and a column. And you can even see it also as a matrix. So if you know what a matrix is, you can also view any data as like a matrix. And each column is like a vector or it's like a 1-dimensional array. So that's all what I wanted to mean by. So I'm not talking about vector in physics, which we say is something that has magnitude and direction. No, that's not what I'm talking about. So what I'm saying is that if I now, let's say, copy this one, and let me open a cell. And then I extract, let's say, and I told you can use the square bracket for extraction, or you can bring a $sign and specify the name of the package. Now, if you don't want to be using $sign, there's a function you can use, but I didn't want you to use that because I will not advise you. But let me show you. You can use something called attach. So let me go back to R for the R Studio for a while to explain something to you. R Studio here. Okay, so you remember now, let's say I type the names of the data, okay. It returns all the variable names, okay. It returns all the variables. Now, so if I want to, let's say, plot histogram, okay, and I just copy, let's say, number of students without bringing the data and the dollar, okay, and let me say I specify the color. I want, let's say, red. See what will happen. I just brought the name of the variable. I didn't bring anything, no dollar, no data. Let me run. I'm getting an error. It's saying that this cannot be found. So the very moment I bring the data, okay, and I bring a $sign, if I run, okay, then it works, okay. Now, if I don't want to be using $sign, what can I do so that it will still accept the variable? So now at the moment, if I run this, it won't accept it. So the very moment I type attach and bring the data name, okay, the very moment I run attach, what it does is that it now helps the software to recognize all your variables. So it means that if you now, at this stage, you can run it without bringing any $sign. Let me change the color to, let's say, blue. So now I've just bring the variable, the name of the variable, and I'm running. It will work. And because now R recognizes now all your variables, so I can put another variable name and it should work. So I can put, let's say, NABCO SH. Let me put this one here, another variable. If I run this, it will also run. Okay, so keep in mind that you can always use attach around your data for it to recognize the variables. But why am I saying that it's not advisable? Suppose you are importing, let's say, two, in R, in Stata and SPSS and the other softwares, you can only work with one data at a time. In Stata, SPSS, Excel, you can only work with one data at a time. But the beauty about any of the programming languages is that you can work with several programs. So now I can import more than 20 data at the same time, and it won't have any problem, okay? But in Excel, SPSS, Stata, eViews, Minitab, you can only work with one data at a time. Now, suppose you are importing, let's say, two data, and the two data, they have some variables that are very similar in terms of the variable names are similar. Let's say one had a variable called BMI, and the other data also had a variable called BMI. The very moment you attach the two data sets, okay, suppose this was the first data set, I've attached it. Now R has recognized all those variables, including that BMI of that variable. And I attach another data, and that data too has a variable called BMI. Now, it will be very difficult for the software to be able to know at which one is using. So that's the disadvantage. But if you are working with only one data, if you want to prevent stress, you can actually just attach the data and then be using the variable names without the data and the dollar sign, okay? But I mean, to be safe, like I said, if we attach more than two data sets at a time, it will be very difficult for the software to be using a particular variable of that data if the names coincide. Or else you are interested in BMI of the first data, but it might be using BMI of the second data. So that's the disadvantage of using the attach. Suppose you want to remove the attach option. Okay, let's say at a point you are importing something that might, so you can use the attach anyway. But let's say you are now importing another data set, or you are doing something else that might you don't want any conflict and confliction with the variables. All you need to do is to detach. To detach, you just type DE, and then yeah, so with this detach the data. So now running this means it has now removed all the variables that I am initially told R to recognize. So now if I should run this, I'll get an error because I have now detached it. So keep in mind, you can use the attach and the detach, and it can be very useful if you don't want to be using dollar signs, the name of the data and the dollar signs. That is fine. So let's go back to the Jupyter notebook. Okay, so Jupyter notebook. Okay. All right, so now let's quickly go through the codes. So now I've imported the data. We know. So now the head. I told you if you run the head like this, it returns all the columns, but just the first 6 rows. Okay, and then I can use the square bracket to also extract. I can use the square bracket. The square bracket. I told you the square bracket is for extraction. If I bring a comma here, whatever I specify here is for the, so if I put 2 here, I'm interested in extracting just the second row. If I put 5 here, I'm interested in extracting just the fifth row, okay? I can now put a C. So the C is what we mean by concatenate, where I'm trying to print out maybe the first row, the fifth row, and let's say the 8th row, okay? I've put nothing at the column, meaning that for the column, I want everything to be there. So if I run this one, it actually returns the first row, the 5th row, and the 8th row, okay? And suppose I'm interested in just the 8th and 9th, I'm interested in, let's say, the 6th and 7th column. I can just put 7 with the column. So don't forget this column is the same thing as saying C, then I bring comma between the 7 and 8, okay? And I run this. So this returns the first, 5th, 8th row, but it returns the 7th and 8th column. Okay, so keep in mind you can use that for extracting. Okay, and then with the head, you can also put comma n equals. Initially, if you don't specify anything, it assumes that the n is 6. Suppose I want to use the head, but return the first 10 elements or the first 10 rows. Sorry. If I run this one, you see, if I specify n to be 10, I can specify n to be 3, and it returns just the first 3. Okay. If I specify n to be, let's say, 10, it returns the first 10. You can also use tail. Tail will the head is returning the first 10. Tail will return the last 10. So keep that in mind. The head returns the first 10. Tail will return the last 10. So if I run this one, it will also return the last 10. Okay. So keep that in mind. So let me just use head, and we are good to go. Fine. So now we are done, and then we learned how to assign names to the category. So we said sex of school was originally coded as 123, if you import it into R will not be able to automatically detect that it was a factor. So in this case, so now if I try to look at levels of this, I told you the levels helps you to know how many the categories. If I run this one, it return now. Now, because at the moment R sees this one as, it sees the sex of school as something numeric because I entered it as 1, 2, and 3. If I want R to see it as or treat it as a factor, I have to bring as dot factor around this, okay, or else now it will tell me the distinct categories in there. So keep that in mind. Fine. So now you can always use that to know the number of categories. If you know ahead of time that that is supposed to be a categorical variable, then you now use the labels to give the names. So one is male and so on. Okay, and the region as well. So we won't go into that. Now keep in mind that we can use tables also for cross tabulations. Okay, so now I can type table in brackets and I can just bring, let's say, now I've already run this one. Okay, I've assigned the codes to the region and I've assigned the codes also to the sets of school. All right. So don't forget this will also be uploaded on YouTube. So you can always watch at your own pace. Okay. So now let me run table and then the region. So I'm trying to extract region. Now see what happens. So now this tells me we have nine of the schools were belonging to Ashanti, 4 Greater Central, and 6 Accra. Okay, now suppose I bring a comma and bring another categorical variable. In that case, you are doing something called cross tabulation. So it means the same function table, once you bring the first categorical and the second, see what happens. So now it gives you a cross tabulation, okay? So it gives you a cross tabulation of the first one. So the first one will come as this, the columns, and then the second one will come as, will come as the rows, and the second one will come as the columns, and you have a cross tabulation. Now, if we have, this is just representing the number. So this is saying that there are 6 male schools that are from Ashanti region and so on. Suppose I need a proportion, okay? I just have to divide by the length of the data. And to divide by the length of the data, I can either use length in brackets. I can use length of any of the variables. I can even use length of the first one and put it and run that, okay? It works. Or we remember that dimension always returns, so because I don't want to be biased to pick a particular variable, but it works anyway. So I can just put divided by the dimension. Don't forget the dimension returns the number of rows and columns. So if we're interested in just knowing the rows is always the first one. So I'll bring a square bracket and put 1 there. And that will help to extract the number of rows, okay? So keep that in mind. So that also gives me, so these are proportion. Suppose this proportion, I want to convert it to percentages, meaning I'm multiplying each by 100%. I'll just bring a bracket around this one and multiply by 100. And what happens? It now converts everything into a percentage. Okay, so that's the beauty about these things. Okay, fine. What did I wanted to say something. Okay, fine. So let's ignore this. So we are done with this. So now the next thing we are going to do is, remember the variables we have. We had name of school, number of school, up to region. We didn't have any variable called BMI. So suppose in future you are given a data set, and the data set now we have height and we have weight, and we have a formula to find the BMI. And let's say we know that the formula for finding BMI is weight divided by the square of the height. Okay, so this is the formula. So how would we be able to add that additional variable to R? So let me open a script here. So what we are now going to do is that you type the name of the data underscore school. So you realize that in Jupyter Notebook, nothing pops up. So you have to be you should be sure of what you are typing, or else you get errors. And whenever you get an error, always check the error name. Anytime you get an error, check what the error is saying. So here the error said unexpected end of input. So meaning that indeed I didn't complete it. So it tells, so always the error message will give you a hint of what you didn't do right. Okay, fine. So now I want to create a variable called BMI. So I have to specify the data and I put the name BMI. If I wanted to create a variable called, let's say, BMI status, I'd rather use this. At the moment, I'm creating the variable as BMI, okay? And then I told you, let me take away this error message, okay? So I told you, you can either use equal to, or you can use less than with this negative sign to assign. So now we are adding, so when you do this, it is automatically going to add BMI as an extra variable. Don't forget. So now the formula is supposed to be the weight over the square of the height. So just extract the data. What is the weight? So the weight is this variable. So this variable was representing the weight, and the formula is saying divided. So this slanting line is representing division, divided by height. So what was height? So it means, so at the moment, if I had attached the data, I don't have to be using dollar sign. Are you getting the whole thing? So I can choose to attach the data and just use the variable names. And I've explained to you, you can do that. But for now, it's not, I mean, the dollar just makes life also easier. That one makes life even much more easier, but you should be careful. I've explained why. So I just bring a round bracket around it because I'm going to square. Don't forget, I'll be squaring the variable like that. So we use this sign to represent exponent or raised to the power 2. Okay, we use this sign. And then now I put the variable. So what this is going to do is, it's going to consider the first value of weight, which is 77, okay, and divide by the square of 1.77. So meaning that 77 divided by 1.77 square, and then 74 divided, and the answer is what we have here. Then 74 divided by 1.686 square. So it means that creating extra variables to your data is very easy. And R has the ability to do each of them automatically for you. So you don't have to create manually, come and create 77 divided by this. Then when you are done, you come and create this. No, once you specify the whole data set, so you specify, so now this is like, so if I should copy, if I should run this one, this is what I mean by a vector. So all this while when I was talking about a vector, this is like a one-dimensional array. Okay, so what this one means is that this is the first value. So the one-dimensional array means I am storing this whole set of data, and I've packed it like a one-dimensional array, or let me say I have put all of them in something that is like horizontal, right? So if I want to extract the first one, I just have to bring one here, and it will extract the first one. If I want to extract, let's say, the 10th one, I just bring this, and it will extract the 10th one. And if you know, if it's a data comes with rows and columns. So in that case, if you don't bring the column, the comma, and specify whether you're interested in the first row or the columns you're interested, then you get an error. So if it was a data, so suppose I bring the data and I forget to bring the comma, I'll get an error because this, sorry, let me take this T, because still an error, because this one, you see the error message, it says that undefined columns, because at the moment, this is like a data, which is like a matrix, which has rows and columns. So if I bring the comma here without bringing anything after the comma means that I am maintaining all the columns, but I'm only extracting the 10th row, okay? And in that case, it will work, all right? So let me go back to what I was doing already. All right, so now if we extract any column and you run, each column is like a vector. So don't treat that vector like the definition of vector in physics. No, that's not what I'm talking about. It's about how we are storing our data. Okay, so every data can be each column can be extracted as a vector. And to extract any component, you can just bring the square bracket, specify the number, and you are good to go. If it's a matrix or a data frame, don't forget it has rows and columns. So you should bring the comma before it works, okay? All right, so let's continue. So what I was saying is that if I should run this and I run height, let me copy height too, and I put it here. So once I write this function, so this function is just like I'm writing the weight over height square. Now, if I run this one, what this function is doing is that it picks the first value in the vector called weight and divide by the square of the first value, and the next it takes the second, divide by the square of the second in the height, and so on. So it does everything in parallel for you. Okay, so you don't have to do it manually one at a time. All right, so that is straight. So now once we run this one, so now I can delete this. So once you specify the weight divided by, I brought a bracket because I wanted to square. So the weight, so once you bring a square, it will square each of the entries of height. So if I should copy this one once again and open a cell, So if I do this and I bring a square, it will square each of the values that you already had. Initially, the height was Initially, the height was 1 point something. So bringing a square, it will square. If I want to cube each, I just put 3 and it will cube each, okay? So don't forget about that, okay? So if I bring this, it will cube each of them, okay? So that's the beauty, and it does everything at once for you, all right? So that's how simple that is. So now, if I run this one, now it has added the extra variable BMI. Don't forget, I specified that variable here, and then I gave the formula, and now it has computed and added it directly to the data for me. Now, the next thing is we want to categorize the BMI. Now, this BMI is what I meant by continuous. It's a continuous variable in this case, okay? Or it's numerical. Now, I want to now categorize it into 4. That if it is less than 18.5, we should say that individual is underweight. If it is between 18.5 to 24.9, normal weight, then between 25 to 29.9, overweight, and so on. So what we're about to do is going to help you to be able to convert a numerical variable into categorical when it's necessary, depending on the kind of thing you want. Okay, so always is what you want is what you do. So now let's learn how to do that. So now I want to add an extra variable called BMI status. So all I need to do is to call the data underscore school, right? Then I bring the $sign. Now the new variable, specify the name of the new variable. Don't forget, this variable was originally not part. Originally, this is up to BMI. Now I'm adding a variable called BMI status, and I just bring the name. I assign, I can replace by equal to, or this one. I told you this is just a fancy thing. And then I use the function called cat. So cat is what we'll be using to specify to convert your data, your numeric data or numerical data into something categorical. But before then, you have to specify the thresholds you want to cut. Okay, so let's say what I mean by thresholds is what you are seeing, the 18.5, the 24.9, the 29.9, they are thresholds. Okay, so I have to specify the thresholds. So with that, I also bring this. And don't forget, I'll bring a C because I'm creating like a vector of that, of the thresholds. So what I would first, so the first threshold was 18.5, isn't it? And then the next one is 24.9. Then the next one is 29.9. And then the last one is 30, right? Oh, sorry. So I can just say, so up to 29.9. Okay, so that's fine. So these thresholds, now I've specified 1, 2, 3 thresholds. But one thing you have to forget is the extreme point. So you have to start with 0. So I have to start with 0, comma. The reason for the 0 is that it's saying that first of all, I want values from 0 to 18.5 to be the first interval. If I don't bring the 0, it means it's actually going to start from 18.5 to 24.9. I want it to start from, you see, less than 18.5 technically means 0 to 0, but not including 18.5. So I have to start 0 to 18.5. And then the next one will now be from the 18.5 to 24.9. Then the next one will be from the 25.9 to the 30.9. Now the next one can be anything after this. So the best thing is to find the maximum of the BMI. So you see the BMI, I just extracted BMI and I type max around it. So this gives me a fair idea what is the maximum value. So I just now put anything. Since the maximum value is 44.9, I just put 50. I can actually put 46. Since the maximum is just, I'm not going to get anything above that. So I can just put 46. So with this now, I'll now use the cut function and then bring BMI. This is the variable I want to cut. Then I use something called breaks. So these things are something you need to know. If you don't know, you just learn. So, and don't be confused. Why cut? So you just have to know that cut is used to convert your numerical variable into categorical. And there are so many ways you can still do this, but this is the easiest option. Then breaks, then you bring in equals. So now with the breaks is the thresholds. Okay, so I just copy these thresholds and I put it here. Okay, and then keep in mind, you see this one doesn't include the 18. So if I can bring something you call right equals false, or let me say equals true. Let me start with equals true and see what happens. Right equals true. Okay, so suppose I should run this. Let me remove. If I should run this, this is how you are going to see. So it meant the first value of the BMI was in this category. The second value was in this category. But you see that now it is now including, don't forget this value was something between 0 and 18.5. But here we are saying that someone who is 18.5 should not belong to underweight. If it should be someone less than 18.5, right? So it means that I'm not supposed to have the ends here closed. Are you getting me? So it's like an interval. So you can have an interval where you are saying that it should start from 0. At the moment, when you do it this way, it's not starting from 0. But when you do it this way, it means it's not starting from 0, but it should end strictly at 18.5. The very moment I bring false, see what happens. If I bring false, now where we had the square bracket now is now open. So this is just a mathematics principle. When you see a square bracket around an interval, the square bracket means closed at that end. And when you see a round bracket, it means it's open. Okay, open means it doesn't include that. Okay, and technically that's what we wanted. We didn't want the extreme ends because this one is not saying less or equal to. Okay, so we have to now open at the top. So that's basically why I'm saying right equals false, meaning that I don't expect the right part of the interval to be closed. Okay, so that is that. All right, so now if I should run this one, okay, and then let me run and print out the data. Now, if I should run this, it has now automatically created the BMI status, but it's using the original cut, okay? But I know that this one, the BMI was 24.5. 24.5. 24.5 means that 24.5 will be normal weight, isn't it? So I should be able to now tell that, oh, when you see any value between 18.5 to 29.9 is normal weight or something. So all I needed to do was now copy this. So it means after you specify your cut, the variable you want to cut or you want to convert to categorical, you specify your thresholds, and always don't forget the thresholds. You should always start with 0 and end with the maximum of the data, okay? And so don't forget that even though these are the 18, 24, these are the specific thresholds, you should always have those endpoints, or else it will not start from 0 and it will not end at the maximum. Okay, then you now bring a comma and then you put the labels. So now I'm saying that it should now categorize the first cut or the first interval should be underweight. The next interval should normal weight, overweight, and obese as such. So now if I should run this, you now can see it has now converted those intervals with respect to it has replaced it by their actual names. Okay, so that this is how simple you can now convert. So now we've been able to convert BMI the BMI into BMI status. All right. So now, and you can clearly see the variable has now been attached to your data. And keep in mind, suppose you have this data and you want to save this data directly into your repository. Okay, because suppose this data was something that originally we didn't have BMI status and we didn't even have BMI. You've now created it. So maybe it would be advisable. Suppose some people also want that data. Maybe it was a task given to you. They wanted you to do the BMI and extract that as a variable for them. Now you can use this function, write.csv in bracket. Then you put the name of the current name, because now everything is now part of the data called school. Everything has now been added. So then I bring comma, then I bring a quotation. Then you specify how you want to label it. So maybe I want to label it as new data underscore then new. Okay, then you bring .csv. The very moment you run this will automatically go into your repository. If you want to see, let me stop sharing shortly and then open share my repository. So let's share my repository now. Okay, so now if I come to the repository, can you see data underscore school and then the new? So meaning that if you click this, it will now give you the new data that you've created. So this is how easy you can create after creating your data and adding other variables you want to add. You can always save it directly into your repository, just like that with that line of code. All right, so now let me go back to the Jupyter notebook. All right, so now we've saved our new data. That's fine. Now, last week we created our own complex function. We created our own function to do the summary statistics. And the function, first of all, will pick any. So this summary statistics function we created, you can actually use it for any data. For any data. Today I have added more complexity to this. And then, if you remember last week, we had, I think I should go back to the R Studio first. R Studio, okay. So last week when you, let me calm down. So when we created our summary statistics function, you remember, first of all, we specified the variable name, and we said names of the data will extract or will bring out all the names of the variable, and bringing the square bracket and the variable index will extract that particular variable, okay? And then you realize that the mean, I was writing data, then the square bracket and all these. Do you know we could have easily just copied this one, okay? And just create something like, let's say, variable. So with this one means that I can replace wherever I see data with the square bracket with this by this variable. So I can just replace this one by this variable. I can replace this one by this variable, and it will make our code much neater. And we've not changed anything. It's the same thing, just that we've now specified it once, and it will work exactly for us. So I can now replace wherever I see the data with the square bracket with a variable, and you now have something much neater or simpler. Okay, so that's basically what I did in the Jupyter notebook. So keep in mind, we can specify that variable once here, and just say mean of that, median of that, and so on. Okay, so now let me stop sharing this and go back to Jupyter notebook. Okay, fine. So what did I do different? So now what I did, I won't go through because we've already created it. So what I did is now I added something called quantiles, 95% quantile. What is a quantile? So now let me insert something up here. Okay. So if I type quantile, okay, I'll explain what quantile is. If I type quantile and I bring, it's something you can add as to your summary statistics for the numerical ones. So first of all, to remind you, the function we created, first of all, we'll pick the data and ask for each variable, is it categorical or numerical? If it is numerical, originally it was computing the mean, the median, the standard deviation, the standard error. I didn't add the skewness, ketosis, and then the quantiles. Now I've added another function, which is plotting the histogram of that variable in 10. So now what I've done is that it's now going to find the mean, median, standard deviation, standard error, skewness, ketosis, the quantile, and plot histogram of the variable, and even make the color blue. You can change the color, you can add more complexity as you want. You realize that if I don't bring the main with this quotation, it will now print the original. So for instance, this is what I mean. So the data is, the name of the data is data underscore school. So let me just extract the names or the variable names. Okay, so these are the variables. So suppose I'm plotting, let's say, histogram, and I just do histogram, and then I specify, I bring this, and I specify, let's say, student, okay? And I run this. Now, you realize that look at the heading it brought. This is the heading it brought, and I don't think this is the heading you wanted to see. So it's a default heading. It put whatever is here as the heading. You know, this one you can add color. So at the moment, look at also the x-axis. It used that same variable automatically as the x, and this is not a nice x-axis you wanted to use. Probably you wanted the x-axis, the label to be, so you use s label. Then if you wanted it to be number of students, you just put it there, number of students, and you can space it as you want. And then the main. Now suppose the main, I just bring it this way. I don't put anything there, see what happens. It means that, let me just bullet this one. So it means that it will now plot it and it won't bring anything. Okay, so basically, if you bring the main without putting anything there, that's what happens. So you see here, the frequency is something, it comes automatically, okay? And here too, you can write freq equals false. So keep in mind, at the moment, this frequency is just representing the actual numbers. The very moment you make it equals false, it will now return proportion, and which it's now called density. So these are just proportions instead, okay? So, and then it's representing density in the case. Fine, so don't forget, you can always add that. And you can always just Google how to do histogram in R. You get a lot of better ways to even make your graphs look nicer, which we are going to see that shortly below. Fine. So basically, that's what I did. Suppose I don't want the Y label to be labeled, okay? At the moment, the Y label is density. Suppose I don't even want to see anything there. I can just bring this and I run and I won't see anything there. If I want to put a particular thing, I can put proportion. I can put anything I want to put there. And when I come here, it will be there. Okay, so don't forget that. Okay, so let's continue. So basically, that's what I did here. So the graph, without bringing anything in the main, is just to take away that default labeling. Okay, so now I was trying to explain the quantile. Let me calm down. Okay, so quantile. So I put the name of the data. Now I can even use the square bracket to extract. I'm interested in the second column. So it's either I use the dollar sign or I just put 2. Okay. So now if I use this quantile, what this has done is the 0th quantile technically is the minimum data. So you find out that if I write minimum in bracket and I put then that particular data there, the minimum is actually the 0th quantile and the maximum is the 100% quantile. Okay, so what the quantile means is that if I say 95% quantile, 95% quantile will return 2 values, and the 2 values it will give so now let's say I want to return 95% quantile. I'll write C here, and 95 I have to consider 0.025, then 0.975. Why am I saying this? Because 0.9, don't forget, you understand soon, 0.975 minus 0.025, let me bullet this, will return 0.95, and 0.95 is 95%, okay? If I want to return 100 quantile, I'll just put 1 minus 0, right? So here, so this returns 95% quantile. See what happens. So what this means is that approximately 2.5% of your data point is below, of the data for the number of schools is below this value. And this one means approximately 97.5% of the data is also below this value. So I was just adding that. So this has computed a 95% quantile. Okay, so don't forget it returns 2 values. So here you have to specify the quantiles you want to extract. Okay, don't forget that. All right, so then that's what I've done. And now I've added a graph to plot histogram for you. So now we'll see everything shortly. And then we also remember, if it is categorical, it should just return the percentages and also the categories, right? We've already gone through this. So if you've not gone through this particular function, try and watch the first video. Now, with the categorical part, you can also tell R to plot a graph. So I just did one for when it's numerical, it should also plot a graph. You'll be given a task where you have to add a plot. When it's categorical too, you should plot something, okay? So now let's see something here. If I should put 2 here, so now let's say you have a different data set and you have this function I've created, which you'll be given. And now if I should put 1 here, suppose I don't even know the names of the variables. If I should put 1 here and I run, it tells me the variable name is name of school, and it gives all the names and it gives the percentages it gives the percentages. Suppose I put let's say 9 or let's say 8. Don't forget 8. Now 8, I didn't even know the variable. Okay, I didn't even know the name of the variable. It tells me it's region. So meaning that this code we have created, we can actually write a package around it and actually make people install our package and use this. And someone can even Don't use that to make money for yourself. But I'm saying that you can actually, this one I've written here, I can actually make it like a package. So that is a package that does this, and it has never been done. There's no package that does this. Okay, so it's something we can actually, it's a novel thing. Okay, and we can add so many complexity, as you can see. Now I've added skewness, ketosis, and quantiles, and even histogram plot. You can add anything you want. Okay, so now suppose I put 2 here, see what happens. I put 2. The 2 was something which was numerical. So it tells me the variable name is number of students. So imagine you don't even know anything about your data. With our function we've created, you can just specify the index number, the name of any data you've imported, and it will do the summary statistics for you. Okay, so here it returns the mean, the median, the standard deviation, the standard error. Suppose you are interested in extracting just the median, just copy this $_mean and paste it here. It will return just the mean. Okay, and now don't forget the plot is already there because the plot will come automatically. Now if you run this without extracting anything you want, so don't forget the $ with the median would extract just the median if that's the only thing you want. If you want to print all, then I don't bring anything at all. Okay, so with this you see that it gives me the mean, the standard deviation, the skewness, the ketosis, the quantiles, and then it plot the histogram. The histogram, it also gives you the histogram plot. Okay, and it even tells the variable, the name of the variable here. So that's the function we've created. So we've done very well, and we can write a package around this. And if someone wants to use our package, the person has to install the package and load it. Okay, fine. So let's continue. So that is basically that. Now let's do some plots. So we have few minutes more. So now we know we've extended the function we created to create other things. So maybe I can tell you to calculate the mode. Now let's be careful. You realize that when we're computing the summary statistics, no one asked me why didn't we calculate the mode. Okay, so for instance, this variable, if I put mean around this one, okay, that's the number of students. It gives me the mean number of students. And if I put median, it gives me the number of it gives me the median number of students. What if I put mode? See what happens. So the mode is just like telling the type of variable. So I can use this mode or class. It tells, so if I use class, it tells me it's an integer value. If I use mode, it tells me something numerical. Okay. So BMI. So the BMI was, and I use this function to print out each variable and its index. So you can go through that. Okay. For looping, it will be something we'll do another time. So for now, I just wrote it for you to be able to know each variable and the index. So if I want BMI, is the index is 9. So I just have to put 9 here. Or I just write data, then the $, then I bring BMI. Okay, so now with the class, see what happens. It also says it's numeric. If I put mode here, it tells me it's also numeric. Okay, so just keep in mind, this mode does not return the normal mode. What is mode? We know that the mode is the number with the highest frequency, if you remember from basic mathematics. And what we were using the table to do is exactly, so if I should type table, see what happens. So it's still table. So I'm trying to find the mode of BMI, the mode. The mode means that I want to find which BMI value had appeared most frequently. So if I run this one, as you can see, this one is just telling me every number is appearing. So it tells me the BMI, the unique values, and this appeared only once. Okay, let me use, let's say, the second value. Okay, so this one is telling me all these numbers are appearing only once. So in this case, if I say what is the mode can be any of them. So something like this, the mode will be difficult. So let me put the 3 and see. Okay, so this one, we can find a mode. And you can see the mode directly, that the mode is 11. Because 11 appeared for, it's 15, because 15 appeared 5 times. Okay, so technically, there's no specific function to calculate mode. So it's a great opportunity for you to create your own function to calculate mode, isn't it? So now the table helps you to know so now the mode is going to be 15 because it appeared frequently. But how would you be able to extract this one so that it will return the mode directly? Okay, so maybe what you can do is, you can bring maybe so let's say this is the variable, and you can now extract and say the max, maybe the max of this one. So the max of this, so I'm keeping the table up there. So what does the max of this do? No, the max is returning, no, not this one. I'm coming. You will come back to that shortly. So it will be an assignment. I'll give you how to create the mode. So I'll give you a function to do that. I think I created in the R Studio. Okay, so now let's continue with the graphs, and then we'll come back to the mode. All right. So now to plot, let's say, so look at this is a bar plot. Okay, so this one is plotting. So there was a school name. There were schools, and I'm plotting the number of students. So for each school, I want to know the number of students as a plot. Okay. So basically, what this function is doing is, so this bar plot. So you specify the name of the function, and then the round. Whenever I use round, it means that I'm rounding the whole of this. I'm running to one decimal place. Okay. So keep in mind that's usually when the very moment you see run, it means I'm going to run to some specific number of decimal places. So that's what I was doing. So I was running the whole of this to one decimal place. Let me take this up. Then I specify the variable names. Don't forget, I want to know the number of schools. I want to know the proportion of the number of the proportion of students across each school. So there's an argument called name.org. Then I specify the name of the argument. So you don't have to memorize any of these codes. Once you get the code, just edit it. So suppose next time you want to now look at the proportion of the number of teachers. Just replace this one by number of teachers, replace this one by number of teachers. And then if let's say you want to do it across BNI status, then you just replace. So let's try one. So at the moment, if I should run this one, it gives me this plot. Now, suppose I want to now do it for a different group. So now suppose I want to plot, let's say the BNI state of the BNI, BMI across, let's say, schools. Okay. So all I need to do is now to replace this one by BMI. And I'll also replace this one by BMI. Okay. And then the name of, so I wanted to do it across schools. If I wanted to do across, let's say, sets of schools, I just have to replace this one by sets of schools. Okay. And then here is because the number of schools how many categories are there? So let's see the number of schools, how many? The number of schools were 19 schools. Yeah, it was 19 schools. So I use so I'm supposed to specify 19 different colors. But there's a function, there's a package that helps me to, so this package, this one, let me copy this. Let me run this. So if I run the brewer.pal and I specify n to be 12, it returns 12 different colors for me. Okay. Don't forget, I wanted to run because the names of schools, this name of schools, let's check how many schools are there. So if I should bring length in bracket, so this returns 9. So there are 19 schools. And so meaning I need 19 colors. At the moment, I have only 12. So I can now bring concatenate sign C and bring this and bring a comma and now add other colors I want to add, so that because now if I bring blue, now I have for myself 13 colors. I can bring red, so meaning that I now have 14 colors. So I'll do that to get 19. Suppose they were just 9 colors. I can just specify the 9 colors. I can just specify the colors to be blue, red, any color you want, just specify, or just Google R colors, and you'll be able to know range of different colors and just use which one you think is looking attractive for you. Now, don't forget, if you bring the $sign, now what you have here is stored as, what you have here is like a vector. If you use dimension around a vector, see what happens. You get null, because this is now like a vector, because each column you extract, it's extract as a vector. It's only when it looks like a data that the dimension will work. So if I should now remove this one, if I should remove this one and run this, then it returns the dimension. Okay, fine. So basically, let me continue from here. So now, So now I've changed the variable to BNI. So here I just have to replace this one also by BNI. So you just, so always you'll be editing the codes. That's about programming. So once you have the codes, that's all. Just edit. So now I did originally for number of schools. Now I want for BMI. So I just edit and use BMI with the same function, BMI. You can now take a bit of, because we don't have time, you can take time and try and understand each line. And each line is something you've already. So this test helps us to add. So without this test, I cannot paste these things here. So the test you are seeing helps me to paste exactly. So now this is telling me is 5.6%. This is just trying to tell me the exact value it was before I converted to percentage. Okay, so that's it. So you can actually remove, if you remove the test. So now if I should remove this test away from this function, or let me just bullet it, you know, you can just bring the hashtag to bullet it. Now if I run, no, let me see. Oh, sorry, the legend instead. So let me take away the legend. So if I take the legend off, now you won't see anything appearing up there, okay? But it's advisable at least for people to know exactly the percentage, because here could have been just 5 people, but the percentage could be 5.6. So it makes sense for them to know exactly how many, what is the exact number contributing to that 5.6, okay? So that's that. Fine. So here, let's finish this one. So I'm changing this one to BNI. And remember, the BNI status were just 3. They were just 3 categories. So I don't need, so it means the colors here, when I was specifying the colors, I can delete all these colors. Let me delete all these colors and just stick to just 3 of them, which I want. So at the moment, I'm using black, violet, and pink. Why? Because they are just, the BNI status is just 3. So it was 4. Okay, let me add. If you want to know how many categories the BNI status was, you can just type levels, then data underscore school, okay, and then we are extracting BMI status, okay. So this one tells me that there are 4 categories, so I need 4 colors. So let me put maybe yellow. Always you can choose any colors you want, and then let's say this is BMI status. So I'm changing the heading, okay. Fine. So at the moment we are good to go. So now, so here the colors you specify here, you have to also specify under the legend color. So with the legend color, so that it will know black represents a particular. So see what happens. So with this, initially there were 19 schools. Initially I was doing it across schools. Okay. Initially I was doing it across schools. Now I'm doing it across BNI. So across schools, I used a matrix. So when you see here, I use the number of columns to be 5. So what it meant, it was because if I didn't bring the column, suppose I make the column to be 1. See what happens. See what happens. It's just returning 1 column, and look at it's not, maybe that this might not be what you want. Maybe this is what you might want. You can put column to be equal to 2. And then you have 2 columns like this. Okay, so you can specify the number of columns anyhow you want. And so for now, I am restricting myself to maybe 1 column. Okay, now let me run this. It says BMI, where? Argument. Oh, sorry. I was doing it across BMI status. Okay, fine. So now let's run this. BMI, name of, oh yeah, BMI status. Um, object BMI. Oh, sorry. So here I'm supposed to, you see here, because I've not attached data, I should bring the $sign, or else it will not recognize BMI unless I attach. Okay. So fine. So now, oh, it gave me that's not what I expected, but I just wanted to have a fair idea. You can just edit and you get your graphs as such. So what this one did was it considered the first individual. The first individual was normal weight, and it just expressed the person's weight as So it considered all the 19 people, and I wouldn't want to use bar chart for that. So this is just to tell you that if you edit the variables, you get a different output. Okay, so if you're interested in pie charts, I will use pie charts for the BNI status if that's what I was interested. And if the categories are more, that's when I'll use a bar plot like this. Okay, so now so I won't, okay, let me delete this. All right, so now to do pie charts, you just go through this code. So what I've done here was I've converted, I want to do a pie chart telling the distribution of number of students across each school, okay? So what this is doing is that the first one is now converting, is now considering the total number of students that are males, okay? Like the total number of students for male school. So this is what I'm doing. So I've considered the number of students and bringing the square brackets and bringing the sex of school equals double equal to males would extract the number of students corresponding to just males. So for instance, if I should run this one here, if I should run this one, um, 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 and then I bring, let's say, a comma here, for instance, okay, let me take this off. Um, oh, number of, okay, let me take this one out. So if I do this, it will extract. If you check the number of schools now, it has extracted only male schools, okay? So you can always use this to also extract a specific category you are interested in. If I put females here, it will extract only female, the data corresponding to just females, okay? Fine. So here what I did was I'm extracting the data, the number of students, and I'm extracting just those corresponding to males, and I'm summing it, okay? And I'm also doing that for male schools. I'm doing that for, so I brought a comma here and I brought a concatenate sign because I'm considering it as a vector. So the sum here is summing all the number of students for male schools. And this sum up to here is summing all the number of students for female schools. And this is doing for mixed schools, okay? And then I am converting it to proportion by dividing by the sum of all of them. Okay, so at the moment I've now converted to proportion. So sometimes you have to do your plot, you have to do some certain things first. Okay, so this one will now help you to know, okay, for male schools we have 47.7%, for male schools we have 47.3, and for mixed schools they were just 56%. This percentage I had to calculate it from here. Okay, so it meant you can do the same thing for if it was the status. You just have to change the number of schools here to BMI status, and you can also do exactly for BMI status. So here to the BMI status, you just have to specify underweight here, the normal weight here, the obese here, and then create another one for overweight, and then you'll be able to also get the pie chart for that. Okay, and the colors, you can always change the colors to suit. I just chose red, blue, and blue, green. You can change any color you want. Okay, so all you need to do is just go through the course which I would upload on Piazza, and then you'll be fine. Now there was a function, there was a package called performance analytics. This particular package, without installing that, you cannot run this. Okay, so what this one means is that I'm considering the fifth, the sixth, and the ninth variable. What were the fifth, sixth, and ninth variable? Let me just run that here. Okay, so that was the height, the weight, and BMI. Okay, and then I want to find the relationship that exists between height, weight, and BMI. So someone could have just done a correlation between any pair. Don't forget, you cannot do correlation between 3 variables at a time. You can only do correlation between 2 variables at a time. Okay, so suppose I wanted to find the correlation between, let's say, BMI. Let's say if I want to find correlation, I use this COR function, and I put let's say I want to find a correlation between the height and BMI. BMI was, the index for BMI was 9, so I just put 9 here. So this one will tell me there's a negative correlation between height and BMI, and you can see from the plot and from the formula. If you remember the formula I wrote, the formula you see, its BMI is weight over height. And since this is a denominator, it means it's inversely proportional. BMI is inversely proportional to height. And so we expect to have a negative correlation between BMI and height. And then BMI is directly proportional to weight. So we expect to see a positive correlation, isn't it? Yeah. So basically, when you see negative for height and BMI, you shouldn't be confused. Let me come down here. Fine. So this is the inbuilt function to find correlation. Okay. So down there, you see that I created up my own function that you can then you compare with the inbuilt to also find correlation. Fine. So now here I extracted just the three variables, height. So you can do that for any data. If you so you will try it using a different data set, which I'll give you as an assignment. So here I'm extracting the height, the weight, and then the BMI. And then I want them, if you don't bring the column names, if I don't bring these names, see what will happen. It will do the plot, but it's used how I label it in the data frame. And this is not how I want it. So see average underscore height. Then, I mean, that's not basically how you want it to, especially if you want to make it professional. So you can now bring this column of the data so that at the end of the day, it will now change the names of those names to height, weight, and BMI for you, okay? And don't forget this height was because the phi variable was height. The weight is because the sixth one was weight, and the 9 because the ninth one was BMI. So now if I run this one, then I get the way I want to specify. And this one returns three things. And you would always want to get this in your data analysis, especially when you want to find correlation between some variables. Suppose there were 9 variables. Suppose I was adding another variable. Let's say I was adding the number of schools and I was adding the number. These are not relevant, but I'm just adding it for you to see what happens. So let's say number of schools is this, and let's say the next one is, let's say, number of teachers. Okay, so don't forget that it's because now I have extracted 3 columns. I have to specify the names as such, depending on how I want. So if I run this, see what happens. So you realize that if you have more variables, you even get much more nicer graphs. Okay, so now you can see it has given me the main column is histogram of each of them. This red is just trying to mimic normality, okay? And then the off diagonals, so this is saying that, let's interpret this one for, let's start with this. This is saying that the correlation between height and weight is 0.051. You didn't see any star. Without seeing any star, 1 star means significant at 5%, 2 star means significant at 1% alpha level, and then 3 stars means significant at what? Significant at, let's say, 0.1%, okay? So meaning that the number of stars represent how much significant it is. If it is just 1 star, it's okay. 1 star, any star means it's significant, okay? Just that 1 star is significant at 5% alpha level, 2 star means significant at 1% alpha level, and 3 stars means significant at 0.1% alpha level. Now, if you want to interpret this one, you just have to look at the variable is height. Look at the intersection, height and BMI. See, so it's height and BMI that intersects here. It's height, the height and BMI that intersects. So this is a correlation between height and BMI. Suppose you want to interpret this negative 0.24. It's actually intersection between BMI and number of schools. BMI and number of schools. Okay. If I want to interpret, let's say this 0.63, it's intersection between BMI and weight. So it means weight and BMI has a significant positive correlation, okay, of 0.36. And then the off diagonals here also tells the scatter plot. And the red lines here also tells whether there's a linear trend, whether it's upward increment or it's downward increment, or it's even curvilinear. What do I mean by curvilinear? You can see from here. So this one is a scatter plot between weight and BMI. And this red line, you could see it's not like a straight line per se. It has a bit of curves. So I can say that this one implies that even though there's a positive correlation between BMI and weight, it appears that the correlation could be upward linear relationship, okay? So at the moment, you could have, so meaning that someone can model such, so if you're using a regression, and a regression, you're modeling weight to predict BMI, for instance, and then you were using a normal linear regression, it meant that it's possible that that variable could be significant, but if it's not significant, it could be due to the fact that you are assuming that there's a linear relationship between weight and height based on your regression, and maybe the actual relationship is a little bit curvy. So you might want to use a nonlinear regression in that case. I mean, we've not gotten to regression and those things. I just want you to note how important the trend here can also mean. See something like this. That when you see something like this, it clearly tells you cannot say there's a positive or negative relationship, right? Because look, it meant as at a point there was a positive and at a point it declined and so on. So this just tells you how, averagely how the relationship between the variables in terms of a scatter plot. Okay, and these are literally like a line of best fit, but it could be a curve depending on the type of relationship. So you might want to have this in your descriptive analysis, depending on the study, okay? And don't forget, you can only do this for numerical variables. You cannot find a Pearson correlation between two categorical variables. It doesn't work that way. If you want to find correlation between two categorical variables, that's when you do a chi-square. So a chi-square test is rather what we use to find correlation or association between two categorical variables. So for instance, if I wanted to find association between the region of school and let's say the sex of school, or BNI status and maybe the sex of school, then in that case, I would want to use a chi-square. So don't forget, this is only when you are dealing with numerical variables. That's why I only extracted numerical variables, okay? So don't forget that. All right, so when you come down here too, I was trying to tell you that there are in plotting R graphs, there are two forms. You have the base plot where you can plot without a package. So these plots here, I'm not using any package to plot them, okay? But this plot, I use a package called the performance analytics. Without that package, you cannot do this, okay? So here, I'm trying to, so here I've specified 3 by 2. So the 3 by 2 here means that I want to plot I'm actually plotting sales graphs, but I want three rows and 2 columns. So that's why we have 3 rows and 2 columns. I could make here 2 and 3, and I just run this. See what happens. Now I'm saying that I want only 2 rows and 3 columns. So that's why I'm getting it this way. Okay. I might not want it this way. Usually you would want your number of rows to be more than the columns instead, and because so that you get much more space. Now the margin here is just to expand the margin. I can delete this margin from here and just be left with the PAL MF row. So this is what we use if you want to plot more than one graph at a time. When you specify 2 by 2, it meant if you plot your first graph, you plot your next graph, you plot your next graph, the first 4, it will plot all those 4 and put it on the same page. At the moment, I've removed the margin. Without remove the margin, see what happens. Now, after removing the margin, if I plot, you see the figures are now looking a bit smaller, okay? That's fine, but I want the margin to be increased. So at the moment, so that I have bigger what do you call it? Bigger view, okay? So fine, so this one I'm plotting sales graph at the same time. So suppose I wanted to plot only 2, I can just put 2 and delete the other ones I'm not interested in. So suppose I wanted to plot only this first one, the second, the third, the fourth. So I'll take this out. Okay, so I'm plotting 4. Oh. So I'm plotting 4. So see, I now have only 4 graphs on the page. Yeah, so now I have, can you see me please? Hello? Hello? Can you hear me? Okay, so I now have only 4 graphs. I think you can hear me. So now I have only 4 graphs on the page. Okay, so now I would undo it so that I have back my 6. All right, so this is how to plot. So these are plots that I did without the package, okay? And then this is just to help you to do, and you can now copy and paste and run these codes also in your Jupyter node, in your R Studio, which I'm going to give you the script. So if I download as an R script, it will save as the normal way you also save your script, okay? So I can put that script on Piazza, and then you can easily also follow from there, all right? And now there's a special package, which I'll not go through much. We call it Ggplot 2, okay? This package helps you to now get very nice plots. It's actually a customized graph, okay, or a customized package. So usually when they are talking about COVID-19 and they are trying to summarize some of these data, maybe UK will be summarizing the prevalence and so on. Most of the data scientists might want to use Ggplot because it's customized. So as you can see, like you can get so for instance, Right now, I am trying to, so here you specify the name of the data, then the X, region of school. Now I want the region of school to be at the S axis, and I want to group by sex of school. So you realize that I want the plot to divide. So you see, sex of school would have its own scatter plot, its own histogram based on the proportion of students. So at the moment, I was interested in looking at the distribution of students. I was interested in looking at the distribution of, let's say, region of schools, but I wanted to specify between male schools. So how many male schools? So for instance, if you look at female schools, it tells me that 20% of the female schools are from Ashanti region, and then 40% of the female schools are from Central, and then another 40% from female schools are from Greater Accra. This one is just saying that all the mixed schools I considered were from Ashanti. That's why it's 100%. There was no school from Central and Greater Accra. Okay, so basically this helps you. So if I don't bring the group, okay, if you don't bring the group, I mean, you get a different output, and you can always play around. So always play around. When you come down here, so here too, I was trying to plot a scatter plot between BMI status and height. But as I was doing that, I wanted to distinguish each of the data points across the BMI status, so that I will know initially if I don't bring where am I? Yeah. So if I don't bring color by BMI status, if I don't bring this, if I take this out, okay, it will give me the graph, and it doesn't say any other thing. It only tells me a scatter plot between BMI and height, and it tells me that it appears there will be a negative relationship. If you are to draw a line of best fit, it will go towards the side, right? Fine. So at the moment, if I should undo this and bring color by BMI status, it meant that it's going to now, if I run this one, it's now going to now distinguish each data point where it really belongs in terms of BMI status. I can change this to, let's say, if it was sex of school, if I replace this one by sex of school, for instance, okay. Now let's see. So it meant the data point, it has now plotted and distinguished between the three sets of schools, okay. So that's the beauty. So you can be playing around these things until you get what you want. So this one is just, I want the X, I'm plotting the height as the X in the X axis and BMI. So I'm plotting BMI against height, but I want to distinguish across BMI status. So that's why I brought color. If I don't bring color, it will just do the normal scatter plot between height and then BMI. That's all it will do. Now this one is when you want to do a box plot. Okay, so if you want to do a box plot, so all you do with the Ggplot, all you do is that you specify the data. Now I want to compare the distribution of the number of students across the region of school. So I just specify. So you just have to specify the variable name. You see here, you don't have to bring the $sign anymore, because once you bring the name of the school, it will recognize each of the variable inside this function. Okay, so I don't bring $sign anymore here. And then the X, if you want to label the X axis separately, this is how we label the Y, this is how we label. Okay, and then this plus the team underscore between. If I should remove this, see what happens is if I remove that function there and I run, then you will see the gray, you see the gray lines. If I don't want to see the gray lines, there are instances the gray lines looks nice. If I don't want to see it, I just bring plus team underscore between, and then I'll have something white. Okay, and I like it this way for this plot, but there are plots I like the gray one. Keep in mind this plus, if you should bring the plus down here, see what happens. If I run, I get an error, because always the plus should always be on the same line as the where this. So for instance, if this was not there, I would take the plus for the plus to start from here. So always you can just bring, you can always bring it here like this. This one can come down, or they can all be on the same line, but never bring the plus to start on a different line by its own. It won't, you get an error. If we now should bring this one together here, then everything works. Okay, so don't forget that. And then with this one too, I wanted to do it's more like I'm also doing a bar plot, but the bar plot that I did with the normal R function without the package, you realize that with this one it even looks much nicer. Okay, so it means with this one you can specify the name of the data, and then I wanted to do find the number of teachers. Okay, the distribution of the number of teachers across the schools. So I just specify the names of the schools and I specify the number of teachers and I get a plot. You can put anything here. Suppose I'm interested in BMI distribution across the schools. I just run this, and then this will give me for BMI. So you see, you are just editing the codes to get what you want, okay? And these codes you don't have to memorize. I've given it to you, I've written it for you. So all you need to do is just to make use of it, edit it to suit whatever you want to do, and you should be fine. When you come down, so something like this, I maintain the gray line because I like it this way. This is the last graph. So at the moment, yeah, so I'm looking at the distribution of the number of NAPCO, NSP, and personnel, and I'm trying to look at based on BMI status. It doesn't make sense, but I was just trying to get a plot for you to have a fair idea. And that's why the last time someone said, don't just get any plots, okay? Make sure the plot you are getting makes sense, okay? So I could have just put, so just look at something like this. If I put number of teachers here and I put BMI status, I mean, doesn't make sense. I mean, even though I'm going to get a plot, it doesn't make sense. So for instance, let's say you find the correlation between, let's say, sex of school and region, trying to say that what the region of school indicates the number of maybe male or female schools. I mean, it might not make sense. Okay, so something like that, if you find correlation between, let's say, even the numeric ones, if you find correlation between age and height, are you trying to say that you want to know whether, depending on your height, can your height influence your age, or can your age influence your height? You see, so always make sure any analysis you do is something that should make sense, or it should be something of interest before you do it. So don't just, but for now you can play around, change the values and see the output. And then that will help you. If you are given a different data set, you should be able to edit these codes and you'll be fine. So the last thing I did, which I will not take you through, was that I created, so this is the function to find the correlation. So if you run the normal inbuilt correlation function in R, so here I was finding a correlation between the height and the BMI, as I did already. So this is the inbuilt function. Now, suppose you were reading an article and you saw this complicated function and you were it was like, oh, this function is scary. And suppose this function didn't have any inbuilt function. We've been able to create it ourselves. And now see, my function is also returning the same value as this. So all what this means is that now this is a function. The n is the number of observation. And this one is saying that for each of the data point, they multiply and sum all of them. And here too is saying that sum all the x's. Here is saying that sum all the y's. And here divide by square root of, multiply the n by, first of all, square each of the x before you sum all. And this one means that sum everything before you square. Okay, sum all the x before you square. So if you're able to interpret the formula, you shouldn't have a problem creating it yourself. So here, the n here is just the length of, I just said length of x. Don't forget that anytime you're finding the correlation between two variables, the variables will have the same length. So if you cannot find correlation between, let's say, a data that has, let's say, 10 data points, let's say if BMI had 10 data points and then height had 8 data points, the correlation will not work because you get an error. Okay, always the data will have the same length. Okay, fine. So so in that case, so the n can be the length of any of them. So that's why here I said length of x or length of y. And then the numerator. So this code I've written here is so simple to compute the numerator here. So the numerator here, so the n is just the length of any of the variables, and then the n times. So this sign, okay, asterisk or whatever, represents multiplication in R. And don't forget that the division, this one represents the division sign in R, okay? And if you don't bring this one, you get an error if we should run this, okay? Because here, it only, if you don't bring this, it will not assume that you are multiplying n times the sum. So here, don't forget this one is I'm summing x and y. So just here, I just wrote sum, then x times y. And here, you sum all the x's and times you sum all the y. So here, just see minus sum all the x's times sum all the y. You see, it's so simple if we are just coding it like that. So what you need to do is that look at this formula, and then when you go back, when you during your own leisure time when you are studying, look at the formula and see how I was coding the numerator. So this is just the numerator. So the denominator, the big square root is just the square root. And then this n, the n, I'm summing the s squares. So first of all, sum then s squares minus sum all the x's, before you square. Okay, so this part is just computing the first part of the formula. This part, this is just like the variance of x, and this part is the variance of x, literally, fine. So then you take the square root, and then you are good to go. And then here, don't forget, I am considering the numerator divided by the denominator, because it's the whole numerator divided by the square root of this. And then I'm returning, I could have just I could have just taken away this paste, okay, and just say return results. If you don't return the results, suppose I comment this, I didn't return any results. Let me run this and see. Nothing pops up because you are not telling R to bring out the output. So you only return what you want. Okay, so if I could have returned just the numerator by putting numerator here. I could have returned the numerator, the denominator, and the results at the same time by just bringing list in bracket, the numerator, the denominator, and then the results. Okay, now I'm just interested in the correlation, which is the results. So I just run this, and then now I have this. Okay, but so now we have the same correlation, but I brought the paste just to say that. So the paste helps me if I want to add extra comment. So I just said it should paste the correlate. So it should write correlation based on own function equals. Then I brought the results. And then if I run this and I run that, I get what I put here equals, then the results comes. Okay, so basically this will be the end of the class. We've taken too much time today. And then so yeah, so in summary, what we've learned is how to first of all create a numerical variable. If you are given, let me take it back. So all we learned is how to first of all create extra variables. Suppose you have some numerical variables, or you have, let's say, a variable or set of variables, you want to create extra ones from it. We've learned how to create it, like creating BMI and then BMI from height and weight. Okay, we learned how to do that. And we learned how to convert the numerical variable to categorical. And we saw how we did that. And we saw that I can use the cat function and you specify the names of the categories. And now we've learned different plots, and we learned that we can actually plot in R without a package. But we have some customized packages that helps you to get customized plots. And Ggplot is one of them. And the performance analytics also help us to get that correlation matrix plot that returns the scatter plots, the histograms, and also the correlation value and whether they are significant. So those are something very useful. You can also use for your descriptives. So now all you need to do is that sit down. I'll give you a different data set, but use the same data set and play around with the plot. And don't forget to install the packages first, because if you see the very moment you see libraries, it means you have to install all those packages first by using the normal, at the beginning, I showed you how you install, or you can just type install.packages, then you copy and paste the name of the package and you run. After installing, you don't need to install that package anymore, okay? Then always you have to bring the library, because the library is what would now make you load the package. Without that, you'll not be able to use the functions that the package has to offer, okay? So I will end here, and then I'll take any question if you have. So I'll stop here, and thank you very much. And let's meet us. We'll meet next week. And don't forget, because the UK time is changing, it's going back 1 hour. So next week we are still going to meet on Saturday 4 p.m. But the Ghanaians and the UKs will have the same time, 4 p.m. GMT. It goes for both the Ghanaians and the UKs. I think the Europeans will be 6 p.m. SET, I guess. All right. So thank you very much, and then happy to have you here. Thank you.